Hi folks, we are on page 16 for lesson 1.2. We're going to look at rational and irrational numbers. Okay, so now we have rational and irrational numbers. These are all real numbers, but we have two main groups, rational numbers, and then anyone that's not rational is irrational. So let's look at rational numbers. Rational numbers are any counting numbers. So like 1, 2, 3, 4, comma. So the square root of 4 equals 2, and that's a counting number. So any regular counting number, a whole number, positive. 0, any negative whole numbers. So negative 5, negative 16 divided by 4 is negative 4, negative 1,000. So fractions, decimals that end, we call those terminating decimals. Decimals that repeat with the bar over them. So those are all rational numbers. So I have perfect square roots. Again, square roots can be solved to a whole number. Then whole numbers, positive or negative. 0, fractions, decimals that end and decimals that repeat, terminating and repeating decimals. Okay, now if numbers don't fall into those categories, any of those, then they're irrational numbers. So really the only kind of irrational numbers are decimals that never end, such as this one. And it doesn't have a pattern either. So decimals that don't, they keep going with no pattern. 1, 2, 1, 1, 2, 1, 1, 1, 2. See, the same pattern is not repeating. Pi, that's a never-ending decimal. We just shorten it to use 3.14, but it is a never-ending decimal. So that's irrational. The square root of 2, the square root of 3, the square root of 5, the square root of 6. If you plug those into the calculator, you will get a never-ending decimal with no pattern. Those are irrational. Everything else is rational. Okay, so let's classify. So let's take a look at right below page 16, on the bottom of page 16. So we're going to call these rational or irrational. Okay, folks, any number that repeats is rational. So we're going to put that here. Okay, any decimal that ends, that's rational. So terminating and repeating decimals are rational. Okay, decimals that never end and have no pattern. 2, 3, 2, 3, 4, 2, 3, 4, 5. So the same pattern is not happening. Those are irrational. Okay, square roots that are not perfect squares are irrational. If I plug in the square root of 62 into the calculator, it's not going to give me a whole number. It's going to give me a never-ending decimal. Fractions are rational. Remember, that's on the rational list. Okay, let's take a look at page 17. Let's try another one. So let's take a look at number 11. Let's classify this list as rational or irrational. Okay, so which numbers are rational? Okay, so I'm going to go down this list. Okay, whole numbers are rational, so 26. 9. 0 is a rational number. Okay, fractions are rational, so negative 3 halves. Now, the rest are irrational. So remember, square roots that are not perfect squares. Can you think of a number times itself that equals 45? No. So if I plug this into the calculator, I'm going to get a never-ending decimal that does not repeat. And then remember, decimals that keep going and never end with no pattern, those are irrational. 7, 3, 7, 7, 3, 7, 7, 7, 3. So the same pattern is not happening. That is irrational. Okay, let's try this one on the back. Let's take a look at this one. So it says you're given the expression 76 plus n, the square root of that, and the square root of 2n plus 26. What is the smallest value of n? The smallest number you can come up with for n that will make each number a rational number. So since we're talking about square roots, I want to figure out what does n have to be in order to get a perfect square number, a rational square root. Okay, so let's start, since it says smallest, let's start with the number 1. I'm going to plug in 1 for n. So 76 plus 1. Doesn't that equal 77? Is the square root of 77 rational? Nope. I'm going to get a decimal. So 1 doesn't work. Let's start with the number. Let's go to the number 2. 76 plus 2 is 78. That is not rational either. I'm going to get a big long decimal. So 2 didn't work. Let's go to 3. 76 plus 3 is 79. The square root of 79 is going to give me a big long decimal. That didn't work. Okay, let's try the number 4. 76 plus 4 is 80, and the square root of 80 is not a perfect square. Okay, let's go to the number 5. 76 plus 5 is 81, and the square root of 81 is rational. That equals 9. 9 times 9 is 81. So since the number 5 worked for this one, now I'm going to try it on this one and make sure 5 works for this one. So 2 times 5, remember 5 works, so we're plugging in 5 for n. Okay, so 2 times 5 is 10. 10 plus 26 is 36. Oh, look. It worked for that one too. The square root of 36 is 6. So what is the smallest value of n that would make these rational numbers? It is 5. So the smallest number for n that we found that works is 5. Okay, let's try one more, folks. Let's take a look at right underneath. Let's classify these numbers as rational or irrational. Okay, let's go through this list. Remember, the only numbers that are irrational are never-ending decimals with no pattern, and square roots that are not perfect squares. Okay, so pi. Pi is irrational. Okay, 4, 6, 4, 6, 6. That is not the same pattern. So that's irrational. Remember, in order for it to be a repeating decimal and rational, it has to have the same pattern. Okay, and the square root of 2 is irrational. If you plug the square root of 2 into the calculator, it's going to give you a big long decimal that never ends. Those are the only numbers that are irrational. Everything else is rational. Now, some of you might be saying, well, what about the square root of 1? Well, isn't 1 times 1 equal to 1? Yes, so that is a perfect square. The square root of 1 is 1. So that's a perfect square number. That's rational. Remember, 0's rational. Any whole number, positive or negative. So -6 is rational. And then any fraction is rational. Okay, folks, I hope that helps. See you next time.